Hello, this is the last part of this section 2, which is like introduction to the course and a repetition of some prerequisites which we will need for this course. And the subject is a cosine rule. And I believe that you know this rule from high school, I guess. If not, well, you will just learn about this rule. Let's start. So the title is a cosine rule, and well, you know Pythagorean theorem. You know that it's only for right triangles, right? This rule here. And the cosine rule, and actually 3 rules, are kind of generalization of this Pythagorean theorem to any triangle. So here, first I will explain how we used to denote the length and of the sides and the measures of the angles. So the length of sides in a triangle are usually denoted by small letters, usually A, B, and C. And then you have the the Greek letters A, B, and C. Gamma, isn't it G? Well, who cares? It's just the 3rd letter of the alphabet. And, so A, alpha, it's opposite to the side length A. Beta, which is kind of B, is to the opposite of the side with length B. And the 3rd one, gamma, is opposite to the side with length C. And we have those 3 rules which tell us how you compute a squared plus b squared. You see that it's c squared, plus 2 times ab, these 2, times the cosine of this angle which is between a and b, and it is gamma. And observe that it's just the Pythagorean theorem is just a special case of this cosine rule. So imagine that this gamma angle is 90 degrees. Then cosine gamma will be equal to 0, because cosine of 90 degrees is equal to 0 of cosine of pi half. So this term here will vanish. And you will just get the old Pythagorean theorem that a squared plus b squared is equal to c squared. And the same you can the same reason you can perform for if alpha is equal to 90 degrees, then you will have a will be then a hypotenuse, a squared will be equal to b squared plus c squared, or if beta is equal to pi half, then this here will disappear, b will be hypotenuse, and b squared will be equal to a squared plus c squared. So you see that you have 3 rules which are actually more general than Pythagorean theorem. So now you know what it is, so you know the statement of the theorem or of this cosine rule, or rather 3 cosine rules. We will use this rule in connection to a dot product between geometrical vectors. But now I will just show you why this rule is true. So I will show just this first one, and all the and the second and the 3rd one are proven in exactly the same way. You have to rotate this triangle and repeat the reasoning. So what are we doing here? We take the height on the side B, and this height divides then B into 2 length. The first one is length B1 and the second one B2. And we get, from Pythagorean theorem for this triangle and this triangle, which are right triangles because, the height is perpendicular to the side. So we get from this left triangle h squared plus b1 squared is equal to a squared, and from this right triangle and to the right you get h squared plus b2 squared is equal to c squared. So just Pythagorean theorem applied 2 times. And then you of course have b1 plus b2 is equal to b. These two together give the entire length of the side. And then the last one we need is the expression for cosine of gamma. Cosine of gamma is equal to, well, you look at this right triangle. Cosine is equal to b1 divided by hypotenuse. It's a. And now, well, we have to compute a squared plus b squared, and we hope, of course, that we will arrive at this expression. So what we do first is plugging in, instead of a squared, h squared plus b1 squared, and instead of b squared, b1 plus b2 squared. Right? So you see the color coding. The first one is usage of Pythagorean theorem, and the second one is simply taking this expression for b. Well, this is the first step. What do I do next? Well, next I have to compute this square of this sum. And you remember the formula for a square of sum. It is the square of the first one plus a double product of the terms plus the square of the second one. So now we are done with this. And what do we do next? Well, we put together h squared and b2 squared, and we see that it is equal to c squared. So we'll replace this sum by c squared. And here, well, we can add together those two because, well, these are similar terms. So it is just 2 times b1 squared. And this double product is, well, remains as it was. Next, what do we do next? C squared is simply being copied here. And here we see that we have a common factor in these two terms, and this is 2 times b1. So we can factor out from these two terms 2b1, and in the parentheses we will have b1, well, because 2b1 times b1 is 2b1 squared, this first term, and from the second term we have b2, well, because 2b1 times b2 is 2b1 times b2. So we are done with this. And here we replace b1 plus b2 from this parenthesis by b. And now it's just one step to the perfect happiness, and by this I mean this right-hand side of this formula. We can now replace b1 by a times cosine gamma. You see, because cosine gamma is the quotient b1 divided by a, so b1 can be expressed as a times cosine gamma. So we put it instead of b1. And this is exactly what we were hoping for. Well, the right-hand side of this formula. And the two other formulas are proven in exactly the same way. And, well, there is some complication if the gamma here was obtuse. Obtuse means larger than 90 degrees. Then this height would obviously fall outside the side B, right? And then you will simply perform very similar reasoning as before, but you will call this part here for B1. And then you will, well, work with this B1 and B, and, well, the rest will be exactly the same, and it was as it was in the previous slides. You can repeat it on your own if you want to, and if you have problems with this, you can always contact me, and I will gladly answer your questions. And the last slide of this presentation. So we have now those three rules, the cosine rules, and you know about the sign of cosine, right? The sign of cosine is plus if the angle is between 0 and pi half, or between 0 and 90 degrees. It means acute angle. And the sign is minus, it's negative, if the angle is obtuse, meaning between 90 degrees and 180 degrees. So let's have a look at this case where the angle, let's say gamma, is acute. So the cosine then is positive. So this means that a squared plus b squared is equal to c squared plus something positive. This means that c squared is actually less than a squared plus b squared. Not equal, of course, not equal, because equality would mean that we have a right triangle. And if gamma is negative, if gamma is obtuse, then the cosine of gamma is negative, and then c squared must be obviously larger than a squared plus b squared. And you see that if our gamma is obtuse, this longest side will obviously be larger than it would be if our triangle was right. Then we would have A, let's say here, and this C would be shorter than in the case of obtuse angle. And you can also see this like numerically. If gamma is obtuse, then this expression is negative. So if c squared plus something negative must be equal to a squared plus b squared, it means that c squared on its own must be larger than a squared plus b squared. Okay, so now we have repeated the cosine rule or cosine rules, and it was also the last video of this section. Thank you for watching. Bye bye.